So far, the electrophilic aromatic substitution reactions that we've looked at have added substituents to benzene, an unsubstituted benzene molecule. Let's say we start with bromobenzene and we add the nitration reagents. So HNO3 and H2SO4. These are the reagents that replace a hydrogen on a benzene ring with a nitro group. Now the bromine is going to be unaffected, so now our goal is to predict the products of this reaction. Since the bromine remains on the molecule, really we're thinking about where there are hydrogens that can be replaced by a nitro group. So we know there are hydrogens at every carbon, except for the one that's bonded to bromine. And so we might think if we substitute this hydrogen for a nitro group, then our product ends as bromo with an NO2 group at the ortho position. Now, if we were to replace this hydrogen on the left with a nitro group, that would produce the same product. We'd have ortho bromo nitro benzene. We can say the same thing if we replace this hydrogen, if that's substituted for a nitro group. This is another possible product. Now we have these substituents meta to each other, meta bromo nitrobenzene. If we replace the hydrogen highlighted in orange on the left, that would produce the same product I just drew, meta bromo nitrobenzene. And then lastly, if we replace the hydrogen in the para position to the bromine, then we'd end up with para bromo nitrobenzene. Now, we might expect if this reaction were to take place that we'd have a different ratio or a different amount of these products. Since there are two hydrogens that would produce the first product, the ortho bromo nitrobenzene, same thing for the second product, but then only one hydrogen that could produce the final product, the para bromo nitrobenzene, then we might expect, just based on that, that we have a 2 to 2 to 1 ratio of these products. Again, because of the hydrogens that would produce each of these. However, the observed yield of these three products, ortho, meta, and para bromo nitrobenzene, is 36% for ortho bromo nitrobenzene, 2% for meta bromo nitrobenzene, and 62% for para bromo nitrobenzene. So that's what scientists actually observe in reality. And this can be explained through the mechanism, which we will certainly talk about. We can say that bromine is what we call an ortho para directing group. Meaning that if you have a bromine already on a benzene ring, that will result in a higher concentration of the ortho and para products than the meta product. For electrophilic aromatic substitution, substituents are either meta-directing or orthopara-directing. So let's write this down. So substituents are either an orthopara-directing group or a meta-directing group in electrophilic aromatic substitution. Whether something is orthopara-directing or meta-directing depends on largely if it's electron withdrawing group or an electron donating group. So in another video, we'll categorize a bunch of common substituents as orthopara-directing or meta-directing.